Alright everyone, welcome to the first part of this revision series. So we are going to begin with mathematical physics, and in that we are going to begin with our topic matrices. So today I'll only begin by giving you short introduction about all the stuffs that we use in matrices, so that you can have a basic, it will be like a basic revision thing, right? So what exactly are matrices? So matrices are square or rectangular array of numbers or functions. We are having two types of matrices, square matrices and rectangular matrices. Square matrices are having the order n by n, and rectangular matrices of the order n by m. I'll quickly go over all this, okay? So like a 2 by 2 matrix A, B, C, D, this is a square matrix, right, of order 2 by 2. This is the number of rows and this is the number of columns. Rows you will go like this, first row, second row. Columns you will go like this, first column, second column. Okay. Now for an n by m matrix, it can be A, B, C, D, E, F. Okay. So this is number of rows, 1 row, 2 row. So it is 2 by columns, 1 column, 2 column, 3 column, 2 by 3 matrix. It is a rectangular matrix and this is a square matrix. So consider any matrix now, A. This is what? A11, A12, A21, A22. This is a 2 by 2 matrix. Okay. So any element of this matrix can be represented as Aij. I is less than or equal to 2, J is less than or equal to 2. So this is called as its matrix element. That means the elements which are present inside the matrix. A is a matrix element, E is a matrix element, C is a matrix element, just like that. Any element which is present inside the matrix is called as a matrix element. It is as simple as that. So now let's go fast and see some stuffs that you can do with matrices. So I'm just going to consider a very simple matrix, that is 2 by 2 matrix, 1, 2, 3, 4. Okay, these are the elements. It is a 2 by 2 matrix. That's it. Now we can multiply matrix by matrix. So we'll have, if I'd say A into A, this can also be written as A squared. This will be 1, 2, 3, 4 multiplied by 1, 2, 3, 4. Okay. How do you multiply? You multiply this row with this column, right? So 1 into 1 will be 1 plus 3 into 2, that is 6. Then you take this row and this column. 1 into 2 is 2, 4 2s are 8. Then this row and this column, 3 1s are 3 plus 4 3s are 12. Then 3 2s are 6 plus 4 4s are 16. Okay. So this will be 7, 8, 9, 10, and this will be 15, and 6, 6, 12, 2, 22. This is again a 2 by 2 matrix. So the condition for matrix multiplication of two matrix element is that if you're having a matrix A and you're multiplying it by another matrix B, if this is of the order m by n, this should be of the order n by p. Okay, such that these two, here the number of columns and here the number of rows should be same. Only then matrix multiplication is possible. So then we'll get the third matrix which will be of the order m by p. Okay, this is the rule for matrix multiplication. Now we'll go into addition. We can add two matrices, A plus A, so that will be 1, 2, 3, 4, and this will be 1, 2, 3, 4. So I'll add the first element with the first element. 1 plus 1 is 2, sorry, here put 2. Okay, second and second elements, 4, 3 and 3, 6, 4 and 4, 8. This is again a 2 by 2 matrix. So for the addition, the condition is the orders of both the matrix should be same, because we are adding the corresponding elements, right? First element with first element. That is the type of addition going on here. So if both should have the same order, m by n and m by n. Okay. Now we look into the third part, is, let's call this subtraction of two matrices. Same thing, just subtract these two. We'll have 1, 2, 3, 4 minus 1, 2, 3, 4. What will this come out to be? 1 minus 1, 0, 0, 0. This and this element, this and this element, this and this element, this and this element. So it will be 0, 0, 0, 0. This can also be written as 0 matrix. Okay, 0. So again here the condition for subtraction is same thing. Both should have the same order, m by n. Now how do you get a determinant of a matrix? Determinant It is written as determinant of A, or it can also be written like this, determinant of A, like 2 lines and then A in between. So what will this be? Determinant of 1, 2, 3, 4. How do you do this? You multiply this by this and minus this by this into this, right? So this will be 4 minus 3 2s are 6, that is minus 2. That is the determinant of a matrix. For 3 by 3 matrix, how do you do? Let's consider a 3 by 3 matrix B, which is, let's say, 1 2 3 3 2 4 1 5 1. Okay, now we get the determinant of this. You take 1 here and the determinant of the remaining terms. Remove this row and this column. You will get here 2 4 5 1. Okay, then you do minus 2 into again this sum. Remove this row, this column and this row. 3 4 1 1. So this will be 3 4 1 1 plus 3 into, remove this thing and this thing, will have only this term, 3 2 1 5. Do the determinant like you usually do for 2 by 2 matrix and then solve this. Okay, now transport. What is transport? Transport is denoted by a t with a small t at the top. Transport means you're generally going to convert the rows into columns and columns into rows. So if A is 1 2 3 4, we'll take this row 1 2 and write in terms of column. We'll take this row 3 4 and write in terms of column. So that is A transpose. That's it. Okay, then adjoint. So what is adjoint of a matrix? Adjoint of a 2 by 2 matrix is pretty easy. It is written like this, adjoint of A. The adjoint of 2 by 2 matrix is, if A is, let's say, 1 4 2 3, what you will do is replace these two terms. So these diagonal terms, this 4 will go here, this 1 will come here, right? This 4 will go here, this 1 will come here, and then we'll replace the signs of these two. So this will become minus 2 and this will become minus 3. That is how adjoint of a 2 by 2 matrix. Adjoint of a 3 by 3 matrix, you have to find the cofactors and minors in cofactors. So that is a long process. So now the trace of a square matrix. So trace of a square matrix is sum of its principal diagonal elements. Okay, and the Hermitian adjoint. So this you will be using a lot in these matrices. Okay, next we're having Hermitian adjoint. Hermitian adjoint. So what is Hermitian adjoint? Hermitian adjoint is also known as dagger, right? So if I take a matrix A, so the Hermitian adjoint of a matrix A will be represented as A dagger. It is more like a sort of a plus sign, okay, like this. So that is a Hermitian adjoint. What does this mean is, this means you have to do TC. So what does TC mean is that first you have to take the conjugate of every element in the matrix A. What exactly is conjugate? Conjugate means you change the imaginary number plus I to minus I and minus I to plus I. That is what you do for conjugate. And then you do the transpose, T is transpose. Then you do the transpose of that matrix. So you change the rows into columns and then you will get the Hermitian adjoint of that matrix. Now two other things are, what does this mean when two matrices commute and what does it mean when they anti-commute? So commutating matrix means A comma B, commutator bracket, this will be AB minus BA is equal to 0. If this is the case, then those two matrices A and B are said to commute with each other. If the anti-commute means this anti-commute sign has curl brackets, so A comma B curl brackets will be equal to AB plus BA is equal to 0. These things we use a lot in quantum mechanics also. So we'll look these things there also, don't worry. So okay, so these are the basic things about matrices. So we have now reached the end of this part. In the next part, we'll do some different types of matrices. And I'm leaving you with two different questions here. One of the question is that you have three matrices A, B and C. You have to find which of the commutation relation these three matrices satisfy. And the next question is, you are having a matrix and you have to find the inverse of that matrix. Both the questions are pretty easy. I am sure most of you will be able to solve it. If not, do not worry, we'll do it in the next video. till then, take care. See you soon. Peace be upon you.